To graph one period of a tangent function, I'm going to begin by finding the period of the tangent function. To find the period, I'm going to take the normal period of a tangent function, which is pi, not 2 pi like it was for a sine or cosine graph, and divide it by the b value. Remember, the b value is the coefficient of x. So in this case, I find my period is going to be just pi over 3. So again, I'm going to show you the method that I like to use to graph these. There's different methods. When I showed you how to graph sine and cosine, again, I showed you my method, although it's not the only method to use. So here's how my method works. So this time I'm going to draw one period of the graph, but unlike a sine or cosine graph, I'm going to draw the positive and negative parts of this, because the positive and negative sections is kind of where my graph will sort of straddle the origin like we talked about in class. So I'm going to include 0 for the origin. I'm going to include, again, 2 tick marks on the y-axis. Just like I did last time, I'm going to use my a value to find those. I'm going to have a 2, and I'm going to have a negative 2. Now that's not the amplitude, but those will be important points for when I go to graph this in a moment. Next up, I'm going to find my x-axis numbers, and again, there's 5 of those, including the 0. I'm going to take tick marks for the ends of the graph, and to do this, I'm going to take the period and cut it in half. So pi over 3 is my period. Multiplying that by a half, I find out that this tick mark is going to be pi over 6. And this tick mark is going to be negative pi over 6. That's how I'm going to sort of make the one period of this graph straddle the origin, is what I like to say. Those 2 tick marks are not actual points on the graph, though. That's actually where the asymptotes are located. Recall that tangent graphs have many asymptotes through them. So that's where 2 of the asymptotes are located. At this point, now I want to find half again. So I'm going to include 2 more tick marks to get all 5 of them. And I'm going to take that pi over 6 and once again take half of that. So multiply that by a half. And I find out that then this is going to be pi over 12, and that this one over here is going to be negative pi over 12. So there's all the points I need, all the coordinates I need, and now I'll actually graph my tangent wave. One of my points will always be at the origin, so that's one of them. I'll come over here to pi over 12. The reason I put the 2 on the y-axis is that tells me where that point's going to be. And then the negative pi over 12, you probably guessed it, I'm going to go down to negative 2. So like we did with sine and cosine, all our tangent graphs are going to look the same. We know they're different because the scale has changed, but by the looks of them, they'll look the same. So these are a bit hard for some people to draw, so I'll kind of do my best here to show you what they look like. They want to go through those 2 points, and they're going to kind of flatten, curve out, and approach those asymptotes. So there is one period of this first tangent wave. And we'll do one more example just so you have one more to look at, although now's a great time to pause the video and try for yourself if you'd like to do that. So first up, let's go ahead and find the period of this graph. Again, to find your period, take the normal period length of a tangent graph, which is pi, and divide it by your b value, which in this case is pi, so my period works out to be 1. Now what that's going to tell me is these first 2 tick marks on the outside, but it's not 1, because remember I want to split that. I want it evenly split on the positive and negative side. So I'm going to take half of my period and get negative 1/2 and positive 1/2. There's a total distance of 1 between there, so my period is still 1. It's just kind of straddling the axis. At those points, that's where the asymptotes are located. So I'll draw those asymptotes in right away. Next up, I need half of that. Well, half of a half gets me a 1/4 for this point over here, and then half of a half on the other side gets me negative 1/4. Lots of symmetry with these tangent graphs. Finally, I'll need my y-axis numbers. Even though it's not an amplitude, 5 and negative 5 will be important points on my graph, so I'll include those on the y-axis, and again, that's just the a value that I've got there. Finally, I'll go ahead and draw my graph by plotting 3 points, and I'll call it still 5 points because I'll count the asymptotes as points, even though they're not at all points. 1 point will be at the origin. Moving over to 1/4, that point will occur at 5, or that will move up to 5, so 1/4, 5 is a coordinate, and then finally moving backwards, negative 1/4, negative 5 is a third coordinate. So again, all the graphs are going to look the same. They're all going to look the same the way that I do them. However, I know they're not the same because my scale has changed. So again, do your best to kind of get that curve going through those points and then kind of flattening out or straightening up at the axis. Include the arrows, and there, my friends, is a lovely looking tangent graph.